Hoi zusammen. Willkommen bei der PDC, or in English, welcome to the PDC. I'm very glad to have you here listening to my talk. My name is Michael Rees. I'm a lead program manager in the SQL Server Engine team, and I'm here to take you on a journey to venture beyond the relational. Now, what does that mean? Many of you, when you build applications, you have to deal with both relational and non-relational data platforms and datas. And you have to deal with the growth in application complexity that comes from having to manage data that lives outside the database and data that lives inside the database. And you have to build services that compensate for these additional complexity. And you potentially have duplicated functionality, like having to do backup of your data outside the database, as well as backup of the data inside the database, etc. So going beyond relational basically means that we try to reduce the cost of managing all types of data, not just the tabular, rectangular data that fits into your table, but also, for example, your files, XML documents, spatial data, etc. And of course, we try to achieve that in a way that it simplifies the cost of developing such applications. And by, for example, taking existing services that work on relational data also to work on non-relational data, such as integrated backup, restore, or search, and to provide non-relational services to relational data. You could think of, for example, search, full-text search inside the database as something that is originally not really relational in nature. It doesn't operate on rows and columns and cells. It operates on the data inside a large text object. So what I'm trying to convey here is, or what I will convey to you is, that we basically have added lots of interesting new functionality in SQL Server 2008 to facilitate you to venture beyond the relational. And I hope that at the end of this presentation, you will understand some of the additional functionality that we provide in SQL Server 2008 to store and manage unstructured data and semi-structured data as well, and that you have a better understanding of when to use it and how to use it. So let's go on the journey, and we start out with a quick overview of the demo that I'm going to use during the rest of the presentation. So I'm basically having a SQL Server database instance running here. And let me go here to Microsoft SQL Server Management Studio. And inside the database here, I have basically one table that models a simple file system. Now, this simple table here has a hierarchy ID that is a unique primary key. It has a derived column here that gives me the level within the file system hierarchy that is derived from the hierarchy ID that expresses the position within the hierarchy. I use a file GUID here that is required by the new functionality that allows me to store files inside of our binary column. I have a file type that is the types that my file system is supporting. I currently support the following types for promotion: XML, PIC, PANTS, and docs. So these are some interesting file types. You might wonder why I have chosen PANTS, but that's just for the illustration purposes. Each file has a name. It has the data that is binary with this file stream attribute. And I'll go into more detail exactly what a hierarchy ID is, what a file stream is, etc., during the remainder of the talk. We have a customer data property that is constrained by a schema called customer schema. It has this new keyword called sparse, and I will go into more detail during the presentation what this sparse property means, what it enables you to do, etc. Then I have three properties that I promoted for the file type picture, mainly about camera information. I have some PANTS information. I have some document information. And I have something that is another XML column here that is called file properties that says it's a column set. So we will learn more about what a column set is as well. So this table I have created. Now, it's using a file stream column here. So let's go back and see what it actually means to have file stream, etc., and why we introduce such functionality. So in SQL Server 2005, we had a couple of beyond relational functionality already. In the document multimedia space, we have added or improved our full-text indexing story. However, it was still basically integrating with the MS Search component. We didn't have any built-in support in spatial, but many of our partners, like ESRI, etc., had built quite successful spatial solutions on top of SQL Server. We had added the XML data type with built-in XQuery functionality and other functionality to deal with XML data. And we have added, as what I call relational beyond relational support, we had the addition of user-defined types that you could add using CLR extensibility mechanisms. In SQL Server 2008, we have invested much more in this area. So on the document and multimedia space, we moved our full-text indexing that was integrated with search outside the database and actually moved the whole search component into the database itself. That's what we call integrated full-text search, or IFTS. In addition, we have added remote blob, file streams, which are made to manage large documents that are not necessarily living directly inside the database. We have added spatial support, which is not the focus of this talk. I will have a quick slide and point you to the talk tomorrow that is given by Isaac. We did some updates to the XML that I will be talking about, and we did lots of other new functionalities, such as sparse columns, wide table, filtered indices, hierarchy ID, and things like that, that I will go into more detail during this presentation as well. So what do you want to do if you have large blob objects? You basically have currently three options to store that data. You can either use file servers to store the data. If you store data in the file server, you have very low cost per gigabyte. You have streaming performance. You can use your Win32 API. But you have very complex application development and deployment, especially if you have to integrate it with the structured data inside your database. Some examples here are file servers, etc. So if you want to go even cheaper for per gigabyte cost, but still quite expensive because you have to buy a complete external system and get the utmost in scalability and expandability, you often go to what it's called dedicated blob stores. Examples are EMC, Centera, or Fujitsu Nearline. And they have the same problems, obviously, as the file servers, and they are normally enterprise scale only. So you're not going to run your 5-person mom-and-pop shop of that. And then the other database solution is that you take your blob and put it inside the database. You kind of have integrated management. You have data level consistency. Access is transacted, etc. But you don't have streaming support. You get a row set back over TDS, and that's it. You can't use Win32 APIs to access the data. You have file size limitations, currently 2 gigabytes per varchar max or var binary max, and you have the highest cost per gigabyte of all these three solutions. Examples is obviously SQL servers, var binary max. So what do you want to do? You basically want to extend your reach. You want to go from storing the data inside the database and still have access to the data that you have in these remote blob storages, and also have access to the data that you have in these file stream storages, and basically get the best of all three worlds. So how do we do that? We have added a new property on a var binary max column that is called file stream that you just have seen in the code example earlier. It has, among other things, the same APIs that you have with var binary max. So that means you can just treat it as a var binary max. You can do select star on it. You can full text index on it like any other large blob type inside the database. In addition, however, you have additional advantages to it. First, the data is actually not stored in the normal data file of the database. It has its own place, which is inside the file system directly. So that way, we give you the ability to have a dual programming model against the data. You can use T-SQL and treat it like a var binary max, or you can use a Win32 streaming API that provides you including T-SQL transactional semantics. That way, you get data consistency both on the data that is in the file stream as well between the data in the file stream and the data inside the relational database. You also get all the integrated manageability functionality, and you are able to go beyond the 2 gigabyte size limit that you have on var binary max. So you can actually store 10 gigabyte movie if you want to. The size limit is basically given by the file system. Now, just a kind of a caveat here. If you want to use file system for blob data, I would recommend that you do that if your blob data is really large. If your average data size is a couple of Ks, probably var binary max is still sufficient because you don't really need the file stream API access to it. Unless you really want the Win32 file stream API access to it, then of course it makes sense to put it in there. Also, there is a full integration with the SQL Server security stack, obviously, so your access rights are controlled by your access to the SQL Server and not by your access to the box on which SQL Server is running. Remote blob store API is our mechanism that gives you access to the data that lives out in these large blob stores. This is basically just an API that we have intrinsic support for inside the database, and to which these blob store providers like EMC and Fujitsu write provider libraries that then plug in so that the data on their machines is basically integrated into our management environment. The provider API provides a couple of simple services: create, enumerate, fetch, garbage collection, delete. And this basically then means that applications can transparently support different blob stores while programming against SQL Server. So let me switch back to the demo and show you how to use FileStream. Before I go into code, let me give you some DBA information. So if you have a SQL Server instance running, like this one here, and I apologize for the small font, and we look at properties, you will notice that there is a new tab at the top, which is called FileStream. And in order to be able to use FileStream, you have to enable it. So I say here, enable FileStream for Transact SQL access, and enable FileStream for I/O streaming access over a Windows share name, which is MS SQL Server. I did not enable remote clients here because it's just my laptop. OK, so once I've done that, another step that I have to do to enable FileStream is that I actually have to set the FileStream access level inside T-SQL, inside the database. Now, I've already done that, so I'm not going to execute it. And when I create a database, I have to create a file group. So in this case, I create a file group called stream that contains FileStream data. So like I do a file group for my data file, one for my full text catalogs, one for my log file, etc., I do one here for the FileStream. And that's it. Once I've done these 3 steps, I'm ready to go and use FileStream. So let's look at the table again, and let's insert some data. Let's insert some folders that give me structures like programs, documents, images, etc. I've written some sub-procedures here, so procedures that do that for me. And then insert a customer document that is of type XML. I will notice here that I kind of read the XML document from a file here of my hard drive using open row set bulk. I insert images here. You notice here that I kind of create hierarchy IDs, and we'll go into these hierarchy IDs later during the presentation so that you understand what it does. At the moment, just think of it, this is my key for my file internally inside the database. And I read a couple of images that are a couple of megabytes large from the hard drive and put it into the file stream. I also insert a couple of pans here. The pans are basically just some small text files here that go into the data file stream document. And let's execute this. So I inserted these values. Let's take a quick look. Oops, that was the wrong key. So now you see basically what I did here is I translated the ID to something human readable, and you see here that the ID is kind of this hierarchical numbering scheme that you see here. So it's //1/2/11/12/1.1/1.0, etc. So this is kind of expressing the hierarchy, and we'll go into more detail on that. You see the level that has been calculated out of it. You see this file GUID that has been generated automatically when I inserted the data. You see the file type that I've given. So you see a couple of folders, customer, pictures, pants. And you see the name of these documents and folders. You see the data in those cases. So as you can see, data is just of our binary max. And there are file properties, which I go into later. This is kind of the summary over all these sparse properties that I have inserted. So now I have these file data in there. Now let's look at what I do if I do Win32 access to the file data and do that transacted. In order to demonstrate that, I start a transaction here, and I insert a new document called PDC demo doc that happens to be 0 length, so there is no value inside the document yet, and the author and the title is given here. So let's insert this. And for some reason, this keyboard has F4 where I have F5. So I've inserted that one. The transaction is still running. Let's quickly take a look at what the data looks like. So you see here that I have the data. My file stream has an additional method that is called path name. This path name method gives me the actual name on my share on which I have stored the actual file outside inside that file group. And so you can see the file name is on my machine somewhere and has this file GUID as its name. So it's not a really complete file that is called PDC demo doc or whatever, but it's close enough. So I also have a transaction context here, get file stream transaction context. Now this is currently null, and the name is PDC demo doc, and it's the data is 0, so it's nothing there. So let's go over to Visual Studio, where I have written a small app that is basically going to replace the document in there with some file that I have on my hard drive and load the data in using the Win32 API. So let's run that in the debugger so that we can look at it. So now I have to switch over here. And so basically what I do is I replace the value of the PDC demo doc file with the file that I have in demodoc.doc on my machine. So the parameters are good. So now I'm back in here. So the first thing I do is I basically create my SQL connection string, and I open the connection to the server, and I get a new committable transaction that I want to use on the connection. Now this is needed for me to be able to use file stream data because it has to be transacted. Now, and this is not SQL injection safe, I have to apologize, this query is getting the path name and that file stream transaction context that I had earlier out and associates it with the data. So let's run this. And I execute the command, and I read back the path and the transaction ID. Now I can open the file that I want to read from. So this is normal system I/O file stream. I just open that file that I have on my hard drive. But I also open now this new file stream object. And this is the one place where, using SQL Server 2008, I cannot use the normal file stream I/O access to access the file itself, because I have to provide the transaction context. So this is the one place where, unfortunately, I cannot do just save as in my Windows application to point directly into the database. So once I get the file stream, I basically continue to copy the data and transmit and have added the document. So now there's a problem here. I actually just ran through it without running into the transaction problem. So let me continue here. It takes a while until this thing here is responding. So now I have updated the document here without running into a transaction log. So now let's go back here and actually make sure that we are indeed really doing what I'm supposed to be doing. Let me quickly delete the document again. Now let's begin the transaction and insert the document. Now let's go over and change it. So this is the command on the line string. Yes. And now you notice I hang, because now I was running the operation inside SQL Server underneath a transactional context. Previously, I did not. And so now there is a lock here that this one here is waiting for. So let's go back and, into SQL Server here. Let's look at the document here itself again. Now you see there is a transaction context. The data is still 0. Now I commit. And now I go and look at the data again. And now you see that I have loaded the data in using my Win32 app. So let's go back here and see that indeed it has completed. So this gives you transacted access both from your Win32 API and your SQL Server T-SQL environment. So once you have your data in there as a file stream or as a lob, you obviously want to unlock the information that you have stored inside it. And one of the ways of unlocking it is that you use search to search over the documents for certain keywords, for example. Now, in SQL Server 2005, we had all the indexes that we used for full text indexing stored outside SQL Server. And that led to some manageability and scalability issues, even though we improved it quite a bit from 2000 to 2005. The mixed query performance also suffered. Like if you query for some data inside your text document, plus also some relational predicate on, for example, the zip code, you would like to be able to use the cardinality estimates from the zip code to find a better plan with respect to not having to look up all the data outside in your index. And unfortunately, in 2005 and 2000, this was not possible. So in SQL Server 2008, we moved the full text support into the database and have it fully integrated inside SQL Server. So catalog, indices, and stopword list are now inside the database. This gives us many better performance characteristics, such as, for example, if I have such a mixed query like this one here, I can actually now reduce the numbers of searches I have to do for resumes based on the additional filter I have on my zip code. While in SQL Server 2005, I would have to search over all the documents for the resume containing SQL Server there. So we also give you the ability to expose the full text index content and any given word breaker behavior. So you can actually look at the index using a dynamic management function. And we have extended our support for word breakers with both better supportability tools like this ability to look at the behavior, and moved to over 40 word breakers and locale support with supporting the Windows Vista word breakers, etc. So here's a quick overview of the architecture. You have SQL Server, but you also have an additional process that is under control of SQL Server that we call FD host. That's kind of where we put all the processing of the data that we don't control over. Why is that? Well, you still have to run full ifilters and word breakers over your document to extract the properties that you actually want to search on. And these ifilters are not written by us. And to make sure that they are not wreaking havoc with the database, we have put them up into a separate process. They are communicating with each other through shared memory. So if you, for example, index your document from the doc table using the create full text statement there, we actually pass that over to the FD host, where the word breakers, stemmer, ifilters do their magic and create the full text index back inside the SQL Server space. Now, when I run a query, this will get parsed. It will get passed on to the algebraizer, which then does both a SQL algebrization and the full text search algebrization, which consists of parsing, building, applying the language module, and the ranking function. Now, the language module itself is applying the word breakers, stammers, ifilters, etc. out in the FD host process again, which then gives us an integrated query tree that we then apply and process using our standard QO mechanisms, including getting costing from the full text index directly into the query execution engine and the cost and optimizer. So this is now the new integrated query architecture. Now, what does that mean? Well, indexing performance, for example. These are sample queries that or indexing times that we took on identical hardware using SQL Server 7, 2000, 2005, and 2008. You can see people indexing in SQL Server 7, these 20 million documents are probably still indexing now, if they started when we released SQL Server 7. SQL Server 2000 was 20,000 minutes. So they are waiting a long time. SQL Server 2005 and 2008 looks like it's 0. It's not quite 0, and for some reason they did not include that on my final slides here. It's actually 2 minutes in SQL Server 2005, and it's 1 minute in SQL Server 2008. So you can see there is quite a bit of performance improvement that we can achieve. Now, on the spatial side, as I mentioned earlier, we have added new spatial functionality, new spatial data types, geometry, geography, spatial methods, so that you can process your spatial data, and spatial indexing that gives you performant access to it. There's an additional talk tomorrow by Isaac Koonin called BB24 at, I think, 3 o'clock in the afternoon. And I would highly recommend that you go there and listen to him. He's a very entertaining speaker. And he has probably the best insight of what we have done in spatial to communicate to you. He promised me that even if I would attend, I would learn something that I didn't know before. And I was the guy that did spatial indexes, so I'm looking forward to that. So another beyond relational improvement we did in 2005 was XML data type support. In this release in 2008, we didn't do as much investment in the XML area, basically because we first wanted to kind of also gauge a little bit the experiences that people have and identify pain points, etc. And we have, however, addressed a couple of pain points people had. One was our missing XML schema validation support of lax validation and time data types in a consistent way. That made it very hard for people, for example, to store InfoPath documents that actually use lax validation. So we did some improvements there. We also added support for the let clause in XQuery. Some people might find that interesting. We added 2 frequently requested functions through the Connect community website. Lots of people asked us, can you provide us a case-insensitive way of comparing things using the uppercase and lowercase functions? We have added those. But note, like in SQL, if you use them, you will not be able to get an index value lookup, because the index value lookup is obviously not applying the function or taking it into account. And we added support for inserting an XML variable into a document without having to go through lots of workarounds. And just to demonstrate that, let me go back to my demo here. So I'm using, again, my database. And let's quickly look at the XML document that I have loaded earlier. So this is the XML document that I have loaded earlier. It contains a customer document, a customer with name, date of birth. And you notice that the date of birth here has a very high precision and has no time zone associated with it. There is some mixed content here, notes with some additional elements, order, partner here, order date. Order date has a time zone +8. Ship date has a time zone +4, and that's it. Now, this is inserted into a column that is constrained by the XML schema that describes this shape. So we have a document here that contains a number of customers, which are of type customer type with a name, date of birth, which is access date time. And now here the notes is interesting. The notes are a complex content, mixed content base that allows me lax content. Now, what does lax content mean? XML schema has 3 validation modes for content. One is strict content. Everything that appears in there has to be valid according to the definition in your schema. It has skip content, which says, put anything in there, I don't really care. It can be completely wrong. And there is lax content, which is kind of a compromise between the two. It basically says, if I find an element name inside my content for which I have a definition in my schema, it is better valid according to that definition, otherwise I will not accept the document. But if it's not known to me in my schema. I will allow you to keep it there, and I will look further at the next level of nesting whether I find anything that I can validate in. And if I don't find anything, that's fine too. So that's kind of what lax validation does. So in this case, basically, I say if a customer or an order appears inside that lax content, it has to be valid according to the schema. If I find anything else, like, for example, that partner element that I've shown you, that's fine too. You can just add your own markup, and I don't mind. So this is the schema that basically controls this document when I've inserted it. So let's quickly look at when I retrieve it, how it looks like. So as you see, it validated, obviously, because it was inserted. I actually preserve the precision. In SQL Server 2005, I would have rejected that value because it didn't have a time zone. And if I would have added a time zone, it would have given me a much less precise rounding down to the 1/300th of a second that SQL Server earlier supported. And if I have order date and ship date here, if you look at these, I actually did not, I did not normalize them to Zulu time or Z or UTC 0 time, but I actually preserved the provided time zone. So this is the kind of behavior that people expected. And this is, now there is one caveat here. If you have datetime data types in your existing XML documents inside your database, when you upgrade from SQL Server 2005 to 2008, you will have an upgrade step that will look at your schema, identify if you have any datetime data types. If it has, it will say, it will disable all the indexes and ask you to recreate the indexes. The reason why we have to do that is that we had to disallow support for negative years. Now, how many of you would use negative years inside a date-time indication? Good, that's what I kind of hoped. I basically said if anyone uses negative years, he will get my phone number and I will help him personally solving his problem. So, but it means that you have to recreate the indexes because that's when we check whether you have negative years in there so that you can actually go and run a script to update your data and move the negative years into some positive territory. OK, so just to show that we actually do validation, I insert here another customer that, or associated with this variable that is constrained by the same schema, that only has an order date and no ship date. And my schema actually requires you to have both. And just to show that we are not cheating here and just accepting everything, it actually gives me a validation error message saying that the ship date was expected in the order element in here. Now, another XML functionality that I wanted to show you is using a normal SQL variable of type XML and insert this new order into my existing XML document. So now I can write this. Yes?
Will it actually skip the invalid row, or will it just abandon the whole batch?
No, it will. It will abandon the whole batch.
So is there a way we can say that, okay, skip the invalid rows but continue on that?
No, not yet. And I will show you a link at the end of the presentation where you can file a request for that. Pardon? Yeah. See, I mean, you have to loop yourself, but so sometimes you kind of want to avoid having to write looping constructs and do it declaratively. And if you do it declaratively, then you can't easily say skip because we abort the statement. Yes, so you can program it, but it's ugly. So I understand the request there. OK, so let's take this XML variable here and write it like this. How many of you have tried to write this? I hope a few. And probably everyone has made the experience that it gave an error message. So let's try it this time. Oh, it actually worked. So let's see what happens. And I see here that somewhere back here, there is a second order that has been inserted. Here it is. So it actually inserted the data. Now let's see what I would have to write in SQL Server 2005, just to show you what an improvement that is. And this is just one of the about 20 workarounds that I came across and had to make up for people. So again, I have my variable here. Now I declare another variable that I want to update. I take the existing data and the newly inserted data, concatenate it into a new variable. Now, inside that variable, I copy the order that is at the top of the XML instance at the moment underneath where I want to insert it and delete it from there. So I basically move the tree into the position I wanted, and then I go and update the whole document back into the table. So let's execute this, just to show you that this actually works. And it's not too bad in performance in this case, but obviously you see there's much more going on than in the previous case. And now if I look at the data, you will see that I have now 3 orders in here. So I have inserted it as well. So this is kind of a very, another workaround would have been to use dynamic SQL. So this was what we have done in XML. Now let's go back and look at some of the other things that we have done that helps you managing semi-structured data. I'm sorry for the recorders that I didn't move forward to the demo slide. So XML often is used not only for documents, but also to manage what we call semi-structured data. Semi-structured data are scenarios where you use property bags, like when you have lots of distinct properties for different types of things that you want to store inside your database. Large numbers of unique properties, user annotations, etc. Examples are document management systems, like, for example, SharePoint, media stores, and other things. It also means normally that you have heterogeneous record types. You have heterogeneous typing going on if you do that. And that you, for example, might also want to use it for modeling type extensions, inherited properties, etc. Some examples here are product catalogs. Or my file system is kind of an example of that. A file system contains items that have data and names, and then it has lots of additional properties depending on what type of file it is. So what are the characteristics of such semi-structured data? It basically means you have a large number of sparsely populated properties. You have a distinct property sets, meaning each type of thing normally has a well-defined set of properties that is only varying slightly across different instances within that type, but you have lots of different property sets. You have heterogeneous structures, and often you have sets and nested structures as well. So what are some of the requirements that you have? First, if you have lots of sparse columns, lots of sparse properties, you don't want to take up space for things that don't exist. How many of you think that we currently don't use any space if I store a null value inside SQL Server 2005? Yes, so you know it's not very good for sparse properties because every time I have a null value in there, I actually use space. I want to have efficient relational access to the metadata properties. I don't want to have to use name-value pairing tables that don't scale well once I have 50 million of properties or so. I want to be able to have an ability to go and get and set meta property sets generically. I don't want to have to know every time I do an update of my properties what are all the properties for this specific type and have 500 different insert statements. I want to have one insert statement for doing that. I want to be able to index only the parts that I really want to have supported inside my query and not all the null values as well. And I want to be able to deal with hierarchical data. That's where the hierarchy ID comes in, for those that may have paid attention at the beginning. So in SQL Server 2008, we have addressed many of these requirements by adding new functionality, such as sparse columns. Sparse columns is nothing else than a way for us to tell the storage engine, do optimize the storage for sparse columns, meaning do not index or use space for null values. Also, in order to be able to deal with lots of sparse columns and deal with this property set and get scenario, we added white tables that allow you to have 29,000 columns that are sparse on a table, in addition to the 1,000 non-sparse columns that you already got earlier. And column sets is a way of getting at all these thousands of sparse columns in a single way without having to enumerate all of them in your code or in your head. We also give you filtered indices, which is a way to index a subset of rows in a table, and I will go into some samples later. And hierarchy ID is a system CLR type, similar to our spatial types, that gives us a mechanism to support hierarchical organization of data. And if you still don't feel that these functionalities are useful, for example, sparse columns, you still have to know a priori which properties you're actually having. There's still XML there that allows you to kind of bridge the gap to deal with dynamic evolution, where you have open schema, you don't have any idea what's coming down your way in terms of properties, in order to be able to operate on lists and tree objects. So let's look into each one of these features in more detail. We have hierarchical data. Hierarchical data obviously is useful to do any kind of hierarchical data management. My example that I was using is a simplified version of the last bullet point here of files and folders. And in SQL Server 2005, when you were doing hierarchical data, you were basically using a parent-child column or the XML data type. Now, parent-child column gives you the ability to keep the data separate. You have one row per node inside your tree, but which gives you very efficient access to a single node. It's actually, if you just need to find one node, it's still faster than using hierarchy ID. But if you want to have, for example, only a certain subtree of it, then having to write a recursive fixed point query over that parent-child relationship table is not for the faint of heart in terms of understanding how to write a recursive query. And secondly, it's also not as performant as using hierarchy ID, because hierarchy ID, as you will see later, is actually just doing a scan. Now, the XML data type gives you the ability to store hierarchies in its entirety, which gives you very fast get and put. And you can query into it using xquery, but you basically have to change programming models away from your relational model into XML, which is daunting for some. And it's potentially, depending on what you do, might be or might not be as performant. So in SQL Server 2008, we have added the hierarchy ID type. So let's go and quickly look at how that works. Just as a reminder here, in my table definition, I had a hierarchy ID column here. Now, this hierarchy ID column basically is encoding the information. And if you look at what I did here was I used a store proc here to create a root folder and create a subfolder, which basically outputs me the node, the hierarchy ID that has been generated, and inserts some information such as the name of the folder and at what position I'm going to insert it in. So let's look at how I actually implemented that. So here's the root folder. That's very simple. I basically get the root ID, which is a constant method on my hierarchy ID type, and I insert that into the file system. So the root is always slash or binary 0, because hierarchy ID is implemented as a var binary type, basically. The subfolder is taking the hierarchy ID. It's taking the name of the folder, and it tells me before and after which other folder I want to insert it in. And then underneath this parent folder here, and then it returns me the new folder ID. So what do I do here? I take my parent ID. I have a built-in method called getDescendant that takes a before or after. If they are null, it just gives me the first one. If it only before is specified, it will give me the next one after it. And if I give before and after, it basically gives me exactly something in between. And then I insert that. So let's look quickly at the query that I run up here to show how this looks like. So the first column here is basically how these hierarchy IDs look like. And you can notice here that if I insert in between 1 and 2, I will get 1.1. Then I insert between 1 and 1.1, I get 1.0. So what this means is that our insertion mechanism for creating new hierarchy IDs is actually giving me update location insensitive mechanisms to deal with it. So I don't have to go and renumber everything that it comes after it, which is a huge problem that I often have if I do kind of normal path-like indexing based on position. So this numbering mechanism, which we also call ORPath, which we use in our own XML internal implementation since 2005, is basically very stable towards insertion. Now, the other thing is, you might have noticed that I created a index. If I would create a clustered index on this, I would actually order these things in the order. So if I say order by ID, and you see I have, in SQL Server 2008, I have IntelliSense. So if I execute this, now I have all the documents ordered in depth first order. You can see I go down 1, then 1, 1, 1, 1, 1, then 1, 1, 2, etc. So this is ordered in depth first order. And if I add the level here, I can do breadth first ordering. So now I do 1, 2, and then 1, 1, all the ones at this level. So this is very useful for ordering the data. And if I have clustered the data according to one of these orderings, depending on my access pattern, for example, if I go and want to get all transitive files and folders underneath images, my query is just a filter on the is descendant of comparison here. So what this does is it looks for all the parent names equals images, or all the folders with that are called images, and it looks for all the files and folders underneath it using this is descendant of predicate here. So let's run this. This is a single self join. Yes? Pardon? Sure. Let me find the query again. Yes. So
the ID, right?
that's the string representation of the ID. So that's a built-in method that allows, it's a CLR method, so it allows me to get a string serialization out of the binary representation that you see here,
So
which is the actual internal representation.
Row 12 come after row 5? Row 12.
12?
Shouldn't that come?
No, because I do a breadth first. I first order by the level here. And row 12 is level 3,
Okay.
and the other one is level 2. Because I do a breadth first ordering. Sure. And I hope it actually does the right thing here. So now 8 and 9 are next to each other.
Cool.
OK, let's go back to the other query here quickly. Pardon? Yes, so I will get to some of the drawbacks of this thing. So as you can see here now, I found images on all the flowers here. If I say documents here, if I can type, you will see that I get all the documents, etc. And this is just a scan, basically a self-join with a scan. It's not a recursive query that I have to do. So this is much more efficient because it does a full prefix lookup here, basically. And this prefix lookup is actually supported by the QO with tries, so you get some statistics and some cost-based optimizations as well. OK, so that's it for hierarchy ID. Let me go back. Yes? No, it's not. I would recommend that you use the built-in functions because they are more efficient than if you use like. OK, so the hierarchy ID is a system built-in data type implemented using CLR EDT. It's available in the SQL Server types library, so you can also use it inside your normal C# CLR mid-tier client-side environment if you use the library. It's a var binary encoding that is less than 900 bytes in length, which allows you to use it as a primary key. And it basically represents a position in the hierarchy, as we have seen. So this is just showing it on the slide here. And we have rich built-in methods for manipulating the hierarchies at a per-node basis. And so that kind of goes into the comment that somebody made earlier about if I delete something, if I delete the 3 there, 3.1 and 3.2 are still inside my column because I don't have a method that operates on my whole tree. So you would have to write a trigger that then goes and does the maintenance for you. So we are kind of looking at potentially changing that, but and we have some Codeplex code samples, I think, already up that help you kind of understand what to do there. But it still simplifies.
That would also be true for updates, right?
Well, yes, obviously you have the same thing. If you insert something in there, if you want to insert a new thing between 3 and 3.1, you would have to do the renumbering yourself. Because as I mentioned, the type itself is a single instance type. It's not a column thing that knows about the connectivity of these items. On the other hand, it also allows you to model other things than just trees. You can model forests, for example, or some other interesting structures. As I already mentioned, the comparison between the values is in depth first order, and you have arbitrary insertion and deletion points without having to renumber the data on a per instance basis.
So does it also sort it at the data page level?
If you use it as a primary cluster key, yes. So there you use the standard SQL mechanisms for doing so.
So that means the hierarchy ID column should be preferably the primary column?
If you use it for with the intent of having things closely together that are closely nested, then yes, you should have a cluster. You should have a cluster on it.
Might you use this for modeling DAGs as well?
DAGs is a little bit harder because we don't know how they fit into each other. So you would have to use the relational concept to allow you to have 2 parents to be able to make a distinction on that. And I'm not sure whether we have a white paper on that. I know somebody was working on a white paper to describe how to deal with non-tree structures as well. But the last time I heard from him was about half a year ago, and I don't know how far he has gotten. Good reminder that I follow up with him. OK. Now, for the last 10 minutes, let's go to sparse columns. So sparse columns, as you have seen earlier, is an attribute on a column. It tells me that I don't use any bytes for storing my null values. It gives me the ability to collocate the data inside a column, which gives me performance benefits. And in addition, we have actually changed TDS so that if I transport null sparse columns back to the client, I actually still have null compression. So I don't expand it and increase the size of the data back into what it was before when I go over TDS. There is no change in the standard query and DML behavior if you just use sparse columns. We also have white tables and column sets. That means you can have a large number of sparse columns. So you have 29,000 sparse columns, 1,000 normal columns, 1,000 indices, and 30,000 statistics. You have to define a sparse column set, which if you want to have white tables and lots of properties. A sparse column set is an untyped XML column that has a pre-published format, and we'll take a look at it in a minute, that gives you the grouping of all the sparse columns in a table that have a value in there. And this is getting automatically returned if you say select star, if you have that specified.
So usually when you are inserting more number of columns, and if the total row length goes beyond 8,000 characters, the SQL gives you a warning message.
Yes.
So in case of sparse columns, how does it calculate then the total length of the row?
Well, it still does that. I mean, that hasn't changed. The storage engine actually knows about the size still.
So the schema that you have defined is still going to determine the length of your
yes,
length of
sure.
And I saw that the sparse was only being used for integer. We can use it for varchar also?
So let me quickly go and show you the sparseness here. Books Online has a clear explanation of how much space you're going to use and save, depending on each data type, because we have to have additional information. I will show you that in a minute on the slide. But let's look at my sparse columns here on my table. You will see that my customer data XML is sparse. My nvarchars and varchars here are sparse. My ints are sparse. So you can have lots of sparse things. My file property column here is XML column set for all sparse columns. In SQL Server 2008, we only allow you to have column sets for all sparse columns. and not for individual. You could imagine that you can have column sets for only a certain set of columns, but in 2008 we only give you this one option. And so if I go now and actually look at what it means here, just to show you, I can take my sparse columns here and select them like any other relational column. So you can see here name, waist size, inseam, camera, zoom length, and you see lots of null values down here in those areas where it's not applicable. Now, however, since I have a column set, if I say select star, instead of going to get back all these properties with lots of null values, I'm getting the file properties back, which is my XML document. And so down here, for example, for a camera, for the pictures, I only get the properties back that actually have a value in it. So it's camera, resolution, and zoom length. Now, there is more to that. It's nice that I get everything back in one thing. But remember earlier I said one of the requirements is to get property back-centric updates and insertions. Well, let's see what I could do here. So obviously, I can do a simple update of my. So let's look at, I can do a simple update by updating zoom length and name as I would do any other relational column. So let's look at this query first to see what the before state is. So you see here that I have a camera, resolution 10 megapixels, zoom length 200 millimeters. And now I go and change the zoom length here directly. And if I run the query again, you will see now the zoom length has changed.
Wow.
Now I can also do full column set type inserts and updates. So in this case, I insert two new items, a new picture with a camera, zoom length, and resolution, and a new pants with a waist size and an inseam. Now I also have to declare the insertion points. That's why I have all these hierarchy ID statements there. And if I execute this, I now inserted 2 rows. And if I look at the data, in this case, I get first the individual file. I get the file type, camera, zoom length, waist size, and I get the file properties directly as well. So I get both some of the sparse columns as well as the column set. And now you notice that I actually have inserted my new picture and pants with the new camera, zoom length, and waist size, and all the other properties that I have specified here. So I can do inserts. Can I do updates? Of course you can. So in this case, I go and change my empty picture here into zoom length 200 and resolution 12 megapixels. Earlier I had, and removed the camera, so to speak. So if I do this, and I just look at my empty instance, you will notice that the camera has disappeared because I did a complete replacement of all the properties. And I have updated my resolution and my zoom length here. So now the next thing I want to do is, if I have all these properties here, and I, let's say, want to run a query such as, give me back all the pants with a waist size greater than 50. Let's execute this. And let's see how this message performs. So this is about 136 milliseconds. And this, by the way, is a table that has much more data in it. It has about 50,000 pictures metadata in it, and about 500 pans, so that we have about a 1 to 10 ratio in terms of selectivity. And if I look at the execution plan, you see that I still do a table scan here. Now, wouldn't it be nice if I could define an index that says, well, you're often querying for large size pans. I don't want to look at anything. I don't want to have my index use up space for all these other things. I want to have a much more performant query for that. Well, you can do that. So what you can do is, for example, I can create an index that I call plus size pants on my waist size, where the file types is equal pants, and the waist size is greater than 40. I wear a 40, just for your information. So I created that index. And now let's run the same query again. Notice that the waist size here is greater 40, and I search for greater 50. It should be able to find this inside my index. Let's see the execution time. Well, 200 milliseconds. I'm running on a slow laptop. But look at this. I now use an index seek here on my plus size pants index. And I actually do a seek predicate in there that looks for the waist size greater than 50 directly on the index. So I'm actually making use of my filtered index here.
Interesting.
Now, how many of you know Oracle's unique index behavior? A few. You know that they allow null values in there, which is really weird. And SQL Server doesn't so far. Well, we can use these filtered indices also on non-sparse columns. One example here is to model exactly these unique indices that allow multiple null values. So let me drop this table here just to make sure that it's not there. And let's create a new table that has ID here. It says sparse here. It doesn't really have to be sparse. Let me remove that. And now let's insert a couple of values. And just as an aside, you might have noticed I have used this insertion mechanism a couple of times. Isn't that nice? I don't have to write insert 500 times or select union.
Sure.
Just a caveat, though. It actually translates into select union underneath. So if you have 500,000 of those, your query processor will be complaining. So as you can see, the ID now has 1 null, 2 null. So I can create a unique index on this table where ID is not null.
Huh.
So it only enforces uniqueness on the things that are not null. And it did it. So let's insert another one. Oh, it says cannot insert duplicate key. Now let's insert a null. Ha! It worked. So for all those people that had a null unique index envy with Oracle, now you can do it without an envy.
But of course, we can't do that on primary key, right?
Pardon?
We cannot do that on primary key.
No, primary key constraints. It has to be a non-clustered index for your sparse for your filtered index.
On those selected indexes, if you're searching for records that don't fall within that index, will it automatically negate the index and pull the rows that don't apply?
I actually don't know. Do you want to quickly try out?
Yeah.
Okay. If anyone is fine with it, we are running good on time. We're only 3 minutes late so far.
I think it should do a table scan on that.
Okay, so let's see. Let's take this query here. Copy it. You want to look for waist size less than 30?
Yeah.
Or less than 40. Let's say less than 40. Make it a little bit easier. Yes, so that makes it a little bit easier. That makes it a little bit easier, hopefully. Or it's a boundary condition, so who knows. So I doubt it, to be honest. I doubt it that it's that clever. Yeah, it just does a table scan. But it's something, I mean, we would have to understand the negation of the cardinality estimates and so on. So, and I don't think we do that in any other case either at the moment. But it's, again, I have a URL at the end, and you can submit that suggestion. They're actually cheaper. And let me get to why they are cheaper on the slide. OK, so let's go back quickly and look at sparse columns again and go a little bit more deeper in understanding how we actually implement them. So basically, we say that we don't store anything for null values. Now, this means that we have to somehow manage the information about what is null and what isn't null in another way. And this costs us in about 20% CPU overhead. So if I have lots of null values, then that CPU overhead is probably acceptable because disk access is expensive inside the database. And I have to additionally store additional 2 to 4 bytes for every non-null value on disk. So again, if I have lots of null values, that's good. If I have lots of non-null values, I should probably not mark a column as sparse. So our kind of rule of thumb, and there is a formula inside Books Online that gives you more detailed information, is that it's beneficial when the space saving is greater than 40%. Then you should start using sparse columns. So if I have non-sparse column data, then you can see that every cell basically gets its own value, and there's a marker that something is null. If I use sparse column, then for all the sparse columns, I basically have this kind of property vector that I store on a per row basis. Now, obviously, in order to then find, for example, my sparse column 9 on the first row, I have to do a lookup and a jump at time of extraction, which is more expensive than just knowing which column I have to go to. That's kind of the 20% overhead. Also, you notice that for every one of these sparseness, I store bytes to know where to jump to, which I don't have to. So that means that's the additional 2 to 4 bytes that I need for non-null values. But you also notice, if I don't have a value there, if it's null, I don't store anything, so I'm fine. Has another interesting behavior, because if I go and add a new sparse column to this table now, how expensive is that?
Sure.
Nothing. Well, metadata. I have to add some metadata entries. But I don't have to change any values. If I do it on the non-sparse table, I have to go backfill all the null values. So there's an additional advantage here.
Is it a sparse column for
Yeah, I don't see why not. I haven't tried it, so we should try it probably. So filtered indices, we only index a portion of the data in a table. And as you have seen, we actually use it during query and DML optimization. Now, there are currently some restrictions on these. First, we can only do that on non-clustered indices. And secondly, the predicates that you see is very simple. It's column, comparison, value, and or column comparison value, and or column comparison value. So it's not like applying an xquery method on it, or extracting the get path from a file stream, or doing any more complex operations like hierarchy ID, filters, or anything like that. The benefit is that we have lower storage and maintenance costs if you have, even if you have large number of indices, because these indices are much smaller. Because we only index what we really want to have based on the filter. And the performance also is better in the queries because we only have to look at much smaller sets of index data when we actually do an index seek or an index scan, for example. So these are kind of the benefits that we have here. And as you have seen, we even can do subsumption. So if this, and that's one of the reasons why we kept the predicates that simple, is because there we can easily do subsumption comparison. So we know that waist size greater than 50 is fully contained within waist size greater than 40. So to summarize, SQL Server 2008 will make it easier to create such information that deal with unstructured documents, XML, sparse, semi-structured information, etc. And not only that, but it allows you to combine that with relational data to give you reduced management overhead. You only have to back up data once. So your file stream data, if you do a backup, it actually backs up that file group containing the file streams as well. It simplifies the development, and it gives you additional cross-optimization benefits, as you have seen with filtered indices and full-text indexing. Now, let me quickly use a minute to give you a little bit of future. I think I'm fine overrunning a little bit since we have done Q&A during the session as well. These are some of the things we are looking at. This is forward-looking. That's why it's in this teal color. Anything I say here, don't shoot me if you don't deliver, because I will say I haven't said it. We are basically in the beyond the relational space. We are focusing on 3 main areas with different internal priorities that are expressed in the order that we see here. One is that we continue to invest in rich unstructured data investments. So one of the things that we, for example, want to enable is that you use your standard Windows application, say save as, and you can point to something inside the database and save it directly into a cell. So that's something that we are working on at this moment for the next release. We also work on integrating the file stream and the RBS programming model. Currently, these are 2 distinct programming models. I showed you the file stream one. I didn't show you the RBS one. We are working on getting better integration between the two. We're also working on better scalability of file stream. That includes the ability to put file streams off of the actual attached share on which your SQL Server instance is running and put it over into other environments, as well as if you have about 20 million or 5 million, I'm not quite sure anymore what the number is, file stream objects. Since we put everything within a single directory at the moment inside, NTFS, if you have the old 3-name compatibility on, starts to degrade performance, as you probably know. And we are kind of running into that. Currently, we say, turn that damn thing off, sorry. But many people don't have the ability to do so. We also look at improving our property search and promotion story. So instead of me writing handwritten code in CLR that does to do the property promotion, we're looking at some more declarative mechanisms using the full-text infrastructure. And we are obviously continuing to improve full-text search in functionality and scale and performance. We did kind of look for full-text search to work well with about 20 million documents when we started this design. The problem is now people want to have 200 million documents, and it doesn't scale that well. So we're working on improving that. We're also improving on the spatial support, deep spatial we call it. That's like more 2D stuff and potentially 3D stuff, and Isaac will be talking more about that in his talk. And we are also looking at improving our XML performance and scale such that we have smaller blob and indexing size, better QO understanding, and potentially relational access to this promoted data out of XML. And exactly how much we will get to this, that's up to our planning committee, and we are just in the planning phase, so I can't make any promises. But these are the things that we are looking at. Related content, we have a hands-on lab on spatial. We have another spatial presentation. There's obviously my weblog there that can give you some more information. We have already published white papers on file stream and RBS. We have a white paper on what's new for XML. We have a white paper on IFTS. And another white paper on semi-structured data is in the works. And once that is being published, I will put it on my weblog. That is currently a little bit languishing, unfortunately. And I hope that you guys send me email if I don't publish anything. And of course, Books Online has a wealth of information. I mean, almost everything I showed you here, you could have just looked at Books Online. But that's why I'm here. Not quite. You don't have the inside. They don't give you the background information. Now, I would be happy if you give me all 9s, of course, or whatever the highest number is. And don't forget it, because the session also will be available as a recording. So if you want to see sparse columns in action again, feel free to download the video there. Now, I have a little bit more time for Q&A, 3 minutes to be exact. Thanks for your time, and have a good day. Yeah, so probably if you want to ask questions, you can use the microphone or just come up here. I'm fine either way. And here is the link, by the way, to give us feedback.
Can we, with DTL, apply sparse after the table has been created and revoke sparse?
No. The reason why not is because it changes the select star behavior. So we don't want you to have added, so we are conservative here, basically. We know that some people want to like to do that, but one of the problems is if you have a query that says select star, before you have a sparse columns, you get all the columns back, and then you add that column set, then you suddenly, the select star changes behaviors, which breaks all the applications that depend on the other behavior.
For example, you had the ID as a sparse column without specifying an XML set, file set for the. Can I have arbitrarily sparse columns without being members of any property bags?
No, currently the column set covers all the sparse columns. You've seen the syntax where I say column set for all sparse columns. Okay. Potentially in the future, we could say column set for, and then give you a list of column names, for example, but we don't support that at the moment.
If you don't define any column set, there is a default column set for all sparse.
No, if you don't define a column set, you don't have a column set.
We don't have a column set.
Yes.
So why the star behavior changes the semantics?
So if you create a table with, let's say, 3 sparse columns.
With no column set.
but no column set. Then select star gives you these 3 sparse columns back as normal sparse columns, like normal relational columns. So your app expects 3 columns to be returned of int, string, and whatever type. Now you, as a DBA, say, oh, I want to have, for another application, I want to add a sparse column, set for these 3 sparse columns. So I add this now. Now my old app still says select star, and that's why you never should use select star, but anyway, I'm digressing. You say select star. Now suddenly that old application, instead of getting 3 columns of these scalar types, gets 1 column back of type XML, and the app breaks because it doesn't know what to do with it.
Yes, but okay, to my opinion, you punish the forward. Sparse columns can also save space for GUIDs. We have a
Yes.
problem with 4 MTs GUIDs.
Okay.
16 bytes we pay the penalty,
Yeah.
and sparse column could have been
Yeah.
a good idea. But
So,
now
so let me tell you one thing here. I don't punish. We punish the developer to some extent on one side. We save it on the other side. And I think what we are kind of, since this is a V1 functionality, we decided to err on the side of caution. So if lots of people come back and say, oh, I never write select star, come on, I am better than that, we might reconsider it and allow it at some point. Okay. We can always take the... Go there. Okay, thanks.
I congratulate you.
Thanks.
It was a nice session.
Thanks. Thanks.
The rule of thumb.
Yes.
That you mentioned, the 40%.
Yes.
Wouldn't be the same for int and for culture?
It's not the same. So if you look in books online, they have a table there that tells you exactly how much space you use in addition for sparse columns, etc. And I think there's even a formula there that you can kind of plug in and see how it works, etc. Yes, and it's certainly going to be in the white paper as well.
Okay.
Can you do a non-destructive update with a column set? So like you showed before, when you did the update, you passed in the XML, any field that wasn't specified in there was set to null.
Yes, we were thinking of it, but at the moment, but we had to make a decision in terms of shipping it for SQL Server 2008, so this didn't make it. Whether we will be adding it in this release right now heavily depends upon how much feedback we are getting from people, whether they want us to do that. We were thinking about having kind of an indicator that says absence of elements means leave them alone and don't go and change them. And we have developed syntax and stuff like that, but we didn't implement it.
Okay. So just in your example, if I had A there, I had 3 possible columns, A, B, and C. I had A with a value in it, but then I did an update with just B and C. A would be wiped out, and I just have B and C. That's what you're describing, right?
No, that's what we currently do.
That's what we currently do.
But he wants to keep A.
But then
Yes.
so if I want to do the non-destructive, I would just do an update on B and C rather than on the column set.
That or what you do is you get the XML out and do something in the XML and write the XML back in.
But you could just, what you said, just update those 2 columns.
Yes.
Right.